Okay, now we are going to discuss congestion control in network layer. So the first and most important thing, we have to understand the data traffic. Suppose we take an example of our real life. We know sometimes we face, or almost in a peak hours in a day, we face some traffic jam on some specific areas when we are moving from one end to another end. So this will be a difficult task to face time on these traffic burst, so we can't help it, we have to wait there and then go through with it. So congestion or traffic jam is a real life word we use in our daily life, and congestion is a terminology used in networks. So we have to find out the shortest path, we have to find out congestion free path, and a number of different scenarios are there. Similarly, like we faced in our daily life, they are similarly exist in networks as well, because in on subnets of routers, we all know routers have a big responsibility to deliver a packet from one end to another end, or maybe source to destination. So how we can manage this thing? Again, we take an example of daily life. We can see, like on some festivals, or like take an example of Mahakumbh and etc. You have seen that how the traffic administration manages the traffic. They route different form the different routes for the different type of traffic flows. They put some gallery kind of thing with some barricading, so that people cannot go beyond these barricading, and then they move in a zigzag barricading and then appear onto the final destination. So similarly, there are two things. One is whether we are able to avoid this type of congestion or jam. This is one scenario. We have to arrange all these systems for this, so that no congestion can take place. And the second one, if congestion happens, then what will be the solution for resolving the congestion? Although the major thing is that we have to try for not to develop a situation which is known as congestion. Otherwise, network will be choked, all the data delivery will become slow, network throughput will be down. So this is the overall scenario which we are facing in our daily life, and same situation arises onto the networks. So now first define the traffic. So if we define data traffic, then we can see data traffic is a traffic which consists of large amount of data on our subnets, and this can cause the situation of congestion. So there's a term written here which is in a starting line, quality of service, right? We will discuss this particular term separately, because quality of service is also a very important part of this chapter. So now the traffic descriptor and traffic profiles are there. Now if you see the traffic descriptor, then you can see with the help of this graph that on certain time, average data rate, peak data rate will be calculated, and maximum burst size, what will be the maximum burst size of data which routers received. Suddenly 1000 kilobyte data arrives. Normally 10 to 20 kilobytes is the normal situation. Right now, if you see the current situation, this lockdown situation, then we can understand that everything is purely based on online methodology. So now you can see the load on the servers and routers, and you can compare it with the normal days when lockdown were not implemented. So nowadays our routers and servers are heavily loaded, so maximum data burst can be very high. So this particular diagram describes the traffic descriptor. What is the scene of overall traffic on routers? Now, traffic profiles, constant bit rate can be a property of a particular network or channel. Then variable bit rate, data can be variable, and bursty traffic. Sometimes there is no data online, and sometimes suddenly huge data comes onto the line, but it comes in a quantity, so we call it as burst of data. So these two things defines the traffic onto the network in terms of data. And data, obviously, without any mention, we can consider it packets, because data is carried by the network packets. Now, quality of service, as I have mentioned, that quality of service is also a very important aspect, which is defined and it is always written in QoS form. O is a small, Q and S will be in caps. So quality of service basically defines two things. Basically, quality of service defines the overall scenario of this congestion control, so that congestion will never take place, right? So the flow characteristics may be reliability, delay, jitter, and bandwidth considerations. These are the flow characteristics. Flow means from data rate from one router to another router. So these are the different factors which can affect and which can be a cause of congestion, right? So techniques how we can improve our quality of service. Few important methods are defined here: scheduling, traffic shaping, resource reservation, and admission control. These are the points which we will discuss one by one. So now finally we come to the main topic, congestion. Now if you see a proper definition is what network may occur congestion in a network may occur if the load on the network, the number of packets sent to the network, is greater than the capacity of the network. The number of packets a network can handle. N number of reasons can be there. It's not only one reason. The situation of congestion means a jam state. The routers are not able to send data with their normal speed to another router, and this situation is similar to all the routers. Then obviously it's a congestion state. Suppose you are standing on a civil lines crossing, and all the in a center point you consider you as a router, and all the four roads or five roads, whatever roads are there, they are the input and output lines defined. And if all the traffic, everyone start their vehicle and moves forward, then what will happen? That's why traffic signaling system is there, to make traffic, to make a proper traffic shaping so that congestion can't take place. But if everyone will move, then obviously this will create a congestion situation, right? So congestion can be defined once again. So receiving packets, one router receiving packet with high speed, other routers are receiving in slow speed, then all the routers in the chain will become affected, right? Because when router receives a packet, we know that buffers are there. We have discussed window, sliding window, and number of things. Buffers, first packet arrives and stored into the buffer, then different routing table and algorithms are applied, then finally router will be forwarded to the destination line, right? But suppose buffer is full and new packet arrives, then what will happen? Packet will be discarded. And suppose sender is a fast and receiver is a slow, and slow means bandwidth can be less than the sender, maybe hardware and processing unit is slower than the sender of receiving router, then obviously all these things can be a cause of congestion, right? You can see input and output queues are maintained at the routers, and they will process it one by one. Factors, as I have mentioned, packet arrival rate exceeds the outgoing link capacity. Obviously packets arriving on a fast speed and going on a slow speed. Insufficient memory, bursty traffic, suddenly more packet arrives, and slow process. Maybe hardware of a particular router can be less than in the capacity in comparison to other routers, right? Then congestion control and flow control. There is a very small difference between these two. Sometimes we make it or think these two are similar, but congestion control is a global issue because whole network will be jam and choked, whole network or maybe subnets. But flow control is a concept which is related with point to point, just one sender and one receiver, and we are trying to synchronize between these two. I think all of you have remember on data link layer we have discussed this particular thing in detail, and some protocols, uh, automatic ARQ, sliding window, and some other different techniques we have discussed for handling the flow control scenario, right? So congestion control is a global issue and flow control is a one-to-one issue. So now how we can control the congestion? Few techniques are there: warning bit, choke packets, load shading, random early discard, traffic shaping. First three deal with the congestion detection. Mind it, first three are the detection. They are trying to inform the routers, or routers are informing each other that congestion may occur, right? And recovery. The last two deal with the congestion avoidance. Last two are the most prominent techniques to avoid congestion. And first three can be both congestion detection as well as sometimes they also contribute in recovery. Now we will see one by one what are the methodology. Warning bit, a very simple thing. Suppose a particular router sense that it has a number of packets in the memory, no buffer space is available, and other routers are also behaving very slow onto the network, and some other routers are sending data continuously to the main router. Then a special bit in the packet header is set by that particular router that warn the source when congestion is detected. Suppose if I am a router and I have sensed that there is a congestion on next router, then I will immediately inform our predecessor routers, those who are sending data to me, like slow down your data rate or maybe stop your data for some time. A bit is copied and piggyback method means acknowledgement packet is going, and then this particular warning bit also set into the acknowledgement packet, right, and sent to the sender. The sender monitors the number of ACK packets it receives with the warning bit set and adjusts its transmission rate accordingly. Suppose you are going somewhere else, right, and one of your friend is coming back and he said don't go with this path, there's a traffic jam. What you will do, you will change your route, you can wait for some time, or you can go back. It's depend on the situation. Similarly, when router receives, sender router is receiving ACK packets with warning bit by the receiving router, then obviously that particular router has to wait for some time or change their data rate. Suppose sending data on 10 kbps, then it can reduce up to 5 or 4 kbps. So this is a warning bit method. Now then next one is choke packets. Choke means to block something, right? Warning bit is just a warning. It's not necessary router will follow the method to reduce the data rate, but choke packet is a method which is directly an indication to the sending router, like slow down your data rate. Okay, so choke packet is a control packet generated by ICMP protocol, which is also known as source quench packet. Choke packet is also known as source quench packet. Internet Control Management Protocol, ICMP, is responsible to manage all these things because ICMP is a type of protocol which monitors and kind of troubleshooting protocol onto the network. So if obviously congestion is a kind of trouble, and if it is there, then obviously we have to restrict the traffic sent by the center. So choke packet immediately wants or sends the choke packet to the sender, that immediately reduce your data rate, otherwise congestion will take place onto the whole subnet, right? Then hop by hop choke packets. This is very similar to choke packets, but if large network is there and long distance packets are there, then choke packets are not very effective. So hop by hop choke packet means one router will send choke packets to its immediate neighbor router and so on. So in this way we can manage the hop by hop choke packets. Then load shading is also one of the good methods. When buffer becomes full, router simply discard the packet, and obviously when we packet will be discarded, sender will wait for some amount of time and then retransmit it. And we all know retransmission is a big problem for the networks. It very much reduces the throughput of a network. So which packet is chosen to be the victim depends on the application or on the RSS. Suppose load shedding means what? Buffer is full, new packet arrives at the router. Now one policy is there. If we are going to implement load shedding, we can remove older packets from the memory and give space to the new packets. But which packet will be removed? So this can be the decision taken by the protocol, and there is a method which checks the type of packet it is. Suppose you are downloading something, some software or application, then obviously your if your few packets will be missing, then after downloading your setup will not run. So if file transfer or some type of downloading is there which is crucial for the user, then that packets cannot be discarded. But suppose you are watching some video, listening song, then most up to date packet is required. So if audio, video or multimedia packets are there in the memory, then they can be discarded and new one can be entered into the memory, and that can be forwarded to the client. Because obviously we always find out smooth and fast buffering in case of audio, video and some other things. So this is known as load shedding, which is conditional on the basis of data packets into the memory. Okay. Then random early discard is a method which one is all these situations or methods are applicable when the buffer becomes full. So suppose if red method is applicable, then each time packet will arrive. Avg, average queue length, a variable is known as avg, is calculated. If avg is lower than some lower threshold is predefined, then congestion is assumed to be minimal, means there is no chance or less chance of congestion. So we can take space to the new arriving packet. Suppose AVG is greater than some upper threshold, then congestion may occur. So we can not give space to the okay. And similarly, if threshold AVG is between threshold, then obviously it will be probability of congestion will be calculated, right? So these are the few methods which we have seen to check the congestion and avoiding the congestion onto the subnets.